Now for the second part, we're going to look at the half angle identities. Now you don't need to copy this part down, okay, because we already have some of these. And the next slide, I'll show you the half angle identities that you guys have on your yellow sheet that you can use. Okay, but what we're going to go back to is these original things here. Okay, so this was just with the manipulation of the double angle identity. Okay, what they're equal to, we moved some stuff, we divided by the 2. Now, instead of having a one little theta in here, we're going to let the theta be an alpha over 2. So basically everywhere you see a little theta, we're going to go plug theta over 2 in. This is how we come up with these half angle identities ones. So if you take this piece right here and we say cosine of 2 and I substitute in an alpha over 2, that goes from a double angle down to a single. But if I come here and I throw in an alpha over 2, this guy's not a theta anymore. This guy's now theta over 2. Okay, so we do that for all three of those, and we get these three formulas down here on the bottom with a simple little substitution of a half angle. Okay, now, we don't want things that are squared, because that's never enjoyable to work with or to solve with. So what we do is we square root them. You'll notice these guys all have the plus minus out here. These get tricky because you have to go put that plus minus in at the end. So we have to figure out what quadrant we're in, whether the sign's positive, negative there, and adjust it at the very end. Okay? In the formulas, these are single angles. Okay, so we're concerned about the quadrant that alpha's in. For the final answer, we're concerned about the quadrant where theta over 2 is in. Okay, so this last little piece, where the plus or minus sign is determined by the quadrant of alpha over 2. Okay, you don't get these from the original. So wherever alpha over 2 is how you determine these guys. So let's look at an example here. If I give you this, so I'm telling you cosecant's negative 3 over 2. I'm telling you the quadrant for alpha, and I want you to do these three things. Okay. Off to the side here, I threw in all our formulas for half angle just so we have them, so we're able to work with them. Okay. First thing I would do before you even get started here is draw both your triangles. Okay. That's definitely quadrant 3 right there. So I'm going to put this guy in here, and this guy's alpha. Okay. Cosecant's negative 3 over 2. That means the sine is negative 2/3, which means this guy is square root of 5, and it's a negative because we came back. And 5 plus 4 gets us to 9. There's where theta is. If I want to do theta over 2, you have to identify a quadrant for it. So if I know this, if I want to turn this into theta over 2, that means I got to divide this one by 2, and I got to divide this one by 2, which puts it at a 4. So if I know theta over 2 is now bigger than pi, but less than 3 pi over 4, that puts me in quadrant 2. So I don't need to put any signs in here, or any values, but just know theta over 2 is in quadrant 2. That's going to determine our signs at the end of this. Okay, theta is in quadrant 3, theta over 2 is in quadrant 2. Bigger than pi, less than 3 pi over 4. Now we can actually go about doing these. So let's take this first one here. Sine of pi over 2, we go grab our formula from right up here. I'm not going to do anything with the plus minus right now. I'm just going to plug stuff in. 1 minus cosine theta, okay, or alpha. It's not alpha over 2, so we're going to use the blue triangle here. So we come to this guy, we say cosine is negative square root of 5 over 3. So you're going to be real careful how you write these and where you put your negatives. So write them as little fractions within fractions on top of each other like this. Now this entire thing is divided by 2, so there's only one place we had to plug something in. Now it's a matter of simplifying. get rid of the fraction within fraction by multiplying every piece by 3. Okay, don't forget this guy over here too. So this guy will cancel. 3, the double negative goes positive, square root of 5. So you got square roots within square roots. Now this entire thing is over 6. This is as far as I want you guys to get it simplified. Okay, it just gets real ugly after that. But you've only evaluated the formula, but we haven't looked at this yet. Okay, so theta over 2 is in quadrant 2. If we're trying to do the sine of that, it's a positive y, so we're going to leave this guy positive. If you want to put a big plus sign there so you recognize that you've taken that step, then go ahead and do that. Okay, and that's it. Leave your answer like that. Now, cosine of pi over 2, if you come look at the formula, it's the exact same thing, except now this is a plus sign. Okay, so our answer is not going to change very much there. So if we want to do the cosine one, go to our formula. We're going to be using this guy up here. So I'm not going to do anything with the plus minus. I'm going to say 1 plus cosine alpha. Alpha is the blue triangle up here. Okay, cosine is still negative 5 over 3, same as it was last time we did it, but notice our signs have changed here in the middle. Okay, we put this all over 2, and I'm going to pause it here and just give you guys the finished answer. So we do the same simplifying we did last time. You can see the same numbers. The only difference is this guy here, it's now a negative instead of a positive. Okay, but we haven't taken care of this guy out here. Now, I'm asking for cosine of alpha over 2. Alpha over 2 is in quadrant 2. Okay, if I'm doing a cosine of this, this guy's a negative x value, so your cosine has to be negative. Okay, so put a big negative there so you keep that straight. Okay, I always do that as the last step. It's easy to forget, okay, but make yourself go do that. Lastly, we got to do a tangent of alpha over 2. We got one equation. It's down here. 1 minus cosine alpha. We come back to alpha. It's been the same thing we've used twice before now. Now this guy's divided by 1 plus cosine alpha. Okay, make sure you take care of your signs. Simplify this guy. A 3 here, a 3 here, here, and here. So 1 big square root okay. Now leave your square roots within your square roots here. That's okay. We don't want to do anything to that ugly piece. We haven't taken care of this guy here. So I'm asking you to do an alpha over 2. Okay, we go to where alpha over 2 is, and it's in quadrant 2. A tangent in this case is an opposite over an adjacent. That guy right there is going to make this guy negative.